Hey, it's Dr. J. More decimals today, 5.2, the decimal operations. In particular, we're going to do the basic operations of addition, subtraction, multiplication, and division today. Now, I'm going to start off with a disclaimer. All of these calculations can be done on a calculator. However, I would recommend that you learn how to do them without the calculator, and then I will keep my calculator handy, if I need to check my answer, or if we get any strange results, or if I just want a little extra support, maybe to make a question go a little bit faster or something like that. But the main objective here is to learn the classic way to do it, pen and paper or pencil and paper, so that you get the feel for it, and then you can decide for yourself the most efficient way to do it. If we were back in school, back in the classroom, I would probably be walking around being the calculator police, trying to keep you from using your calculator. I'm obviously not going to be able to do that through the virtual medium here. Let's start with addition and subtraction. We'll start with that. Addition, subtraction of decimals. It's exactly as it might seem. I guess I'll start off with something like, 10.93 plus 5.18. So the main thing is to line up the decimals. So the decimals must be lined up. Call that being in line. Now you could just memorize that. When you're adding, it's just as before. It doesn't matter who goes on top. I like to just read it however it comes out and then stack them on top of each other like this. And the decimals must be in line. Now you could just memorize that because that's the rule. And you might have already seen this rule before, but the one thing I'm not sure is become clear over the years is why you have to line up the decimals when you're adding or subtracting in my next example. It's because of place value. Oh, that's a nicer pen. Yeah. When you're adding, you have to have a common denominator. Yeah. It's like an LCD. So when you have 9 actually means 9/10. I'm not really going to write that, but that's what that 9 means. And the 1 is 1/10. So they lie in the same place value, and so when you're adding them, you're adding up least common denominators of 10. Right? Over here, what does 3 actually mean? 3 actually means 3/100ths. And 8 means 800ths. So again, LCD is 100 there. Now, of course, I'm going to put all of this in my mind cloud here because you're not actually going to add the fractions, but in theory, that's what a decimal is. A decimal is a representation of a fraction with a power of 10 in the denominator. The actual process of doing it is relatively straightforward. It's exactly like addition was done in Chapter 1. We start at the far right and we add, carrying over ones if necessary. So 3 plus 8 is 11. I think I'm going to switch to purple because that pen is dead. So 3 plus 8 is 11, carrying the 1. 1 plus 9 plus 1 is another 11, carrying another 1. Bring down the decimal point. 1 plus 0 plus 5 is 6, and there you have it, 16.11 or 16 11/100ths. Let's do another one. It's interesting when I write these things down. That they're typically, the problems as I pose them are typically written horizontally, but the very first thing you're going to do is line up the decimals. And again, it doesn't matter who goes on top. but it does matter that the decimals be in line. If there are any missing place values, those are invisible zeros, which you can either write the zeros if you like. My black pen has actually sort of looked like invisible ink today. You can put the zeros if you like, if it helps you keep track of those place values. But if you leave it blank, it's not going to affect the answer. The most important thing is to line everything up. So you have 5 plus 0, 6 plus 0, 3 plus 0. Bring down the decimal point, and then 4 plus 2 is 6. There you go. That one didn't have any carrying in that example. Subtraction is exactly the same process. So 3.6 minus 2.8. Now be careful with subtraction. The order matters. Very important. Addition, remember, addition, we call it commutative. It means that you can change the order and still get the same result. Subtraction is not like that. The order matters. The first number or decimal must be on top, and the second one must be on the bottom. So it does have to be in this order. If you accidentally do it in the wrong order, you'll get it wrong every time. So I'm subtracting 6 minus 8, or 6/10 minus 8/10, technically what that means. But when you do it in your head, you're just going to do 6 minus 8. You cannot subtract 8 from 6, right? So this is the borrowing process. We're going to borrow a 1, and that's going to make that 16. And then now 16 minus 8 is 8. Bring down the decimal point. 2 minus 2 is 0. And you do have to put the 0. All right, it should say 0.8 or 8/10. I'll do another subtraction. For some of these problems, you might notice that it would take me longer to take out my calculator and actually type all that in than it would have to just do it in that case, right? And when you get to the next class, after this class, when we're doing, intermediate and advanced algebra, you don't want to be stopping every 2 seconds and picking up your calculator to calculate something that you could do much quicker by pen or paper. Okay. There are fancy names for I call this the first term and the second term. One of them is called the subtrahend, and the other one's called the minuend. That's not going to be on the test. But if you wanted to look up some fancy words for first and second term. The first term must go on top. Second term must go on the bottom. And the decimals must be in line. I got some invisible zeros here that I can put them if it'll help me keep organized or keep neat. One of the most common mistakes that I see, and I see it in classes ranging from beginning algebra, pre-algebra, all the way through advanced calculus, is just sloppy writing and not having your numbers lined up, and it causes some error on down the road. So really, it's just about paying attention to detail here. So 6 minus 0 is 6. 5 minus 0 is 5. 4 minus 1 is 3. Bring down the decimal point. 5 minus 3 is 2. Okay. That's the basics of addition and subtraction. The only thing that could make this a little more complicated would be when we run into negative numbers. something like this. So if the subtrahend is larger than the minuend, or in a fancy way of saying if the second term is larger than the first term, this is like spending money that you don't have, right? And this is like you only had $4 and $4.05, and you spent $7.31 or something like that. Okay, so when this happens, you need to switch back to the integer mode when we learned about how the negative numbers and the rules of signs work. So what we're going to do is we are going to subtract. So I'm going to say recall how we did it in chapter 2. Or is it chapter 3? Chapter 2 or 3. We probably did it in both chapters. You're going to subtract 7.312 minus 4.05, but then you're going to make the result negative. Yeah? Because you're subtracting 7, or something that's approximately 7, from 4. And so you know that you're going to end up in the hole. We call that being down in the hole or being in the red. Okay? Negatives. Make sure you line up the decimals. Put your placeholder if it'll help you. It's supposed to be a placeholder of a 0, and just go ahead and do it. So 2 minus 0 is 2. 1 minus 5. Can't do that, so I'm going to borrow from the 3. Make this an 11. 11 minus 5 is now 6. 2 minus 0 is 2. Bring down the decimal. 7 minus 4 is 3. And then make the result negative 3.262. Okay. Basically the same idea as we did with integers and whole numbers. Just got to be a little bit more careful because there's decimals now. Example 6. Something like this. So now you have a negative 15 and a positive 34. So you're going to subtract 34.1 minus 15.3, and the result should be positive. Okay. It's already going to come out positive. I don't have to worry about changing the sign here because 34 has a larger magnitude, a larger absolute value than 15. Okay. So let's just go ahead and do it. I guess I already wrote it over here. So the result will already be positive. I need to borrow right away. So then 11 minus 3 is 8. I need to borrow again. 13 minus 5 is another 8. And then 2 minus 1 is 1. So that's going to be 18.8. Go through and review some of these old rules from the previous chapters. Not a bad idea. So in this time, we're adding two negative numbers. I'm really particular about parentheses when I'm adding and subtracting negatives. So you got to be really careful. Otherwise, you might make some sign error. So this clearly indicates that I'm adding two negative numbers. So this time, I'm going to add 28.74 and 12.2. And again, being very careful to line up the decimals, put a placeholder if it's helpful, and then make the result negative. Yeah. Oh, I should just write the word negative right there so you can read it. And you see why? I hope you see why we're making the result negative. This is like as if you spent $12.20 and then you spent another $28.74 and you put all of this on a credit card where you don't actually have that money. This is all negative money. So, negative, and then you add another negative, you're just going to get deeper into the negatives. So 4 plus 0 is 4, 7 plus 2 is 9, bring down the decimal, 8 plus 2 is 10, carry the 1, 1, 2, and 1 is 4, and make the result negative. Just like you would do with your bank account if you're keeping track of how much you've spent. Yeah. Which, at some point, we're going to have to do some word problems, but right now I'm just getting the nuts and bolts worked out before we get into the big machine here. All right. The only thing that can make this a little more complicated would be multiple negative signs and things like all the same attributes that you would see in other sections with negative numbers. So we could have something like double negative. It's supposed to be a 6. So I got negative 7.5 minus negative 6.4. So I would first rewrite this. You probably heard me say this when I first introduced this concept. I don't recommend trying to just write over it with your pen or pencil. It's better just to write a new line, mainly because as you get into the more complicated problems, that quick fix, I mean, it might work in the beginning, but it stops working as you get deeper into the subject. So it's better just to rewrite those two negatives as a single positive sign and not trying to, just write over the previous line. I know it takes one extra line of writing. And now you want to decide right now if the answer is going to be negative or positive. All right. So again, think of this like money. This means that you spent $7.50, but you only had $6.40. So you can make a very quick decision. If you spend more than you have, you're definitely going to be negative. All right. And now set it up. 7.5 minus 6.4. You always have to put the larger number on the top, smaller number on the bottom. And then when you're done, change the result to negative. I mean, if that's what you decided it's going to be. If you decided it was going to be positive, then make the result positive. When I say make something positive, you don't really have to do anything because it will come out positive already. Just what we call retaining or preserving its positivity. So we're subtracting here. 5 minus 4 is 1. Bring down the decimal. 7 minus 6 is 1. And then make the result negative. It's negative 1.1. You might think, well, can't I just reverse the order, subtract, and have it already come out to be negative? On the calculator, you can. Yeah. So on the calculator, if you go 6.4 first and then minus 7.5, you still get negative 1.1. I don't know if that looks like an 11, but there's a decimal point right there on the calculator. So be very careful with where the decimal point lies. And then finally, there's a hidden addition sign. Was that 7 or was that 8? There's a hidden addition sign in a problem like this. So it looks like you're subtracting, all right? And this is one of those problems where you really have to remember the principle of subtraction. And the principle of subtraction is it's addition of the opposite, right? And so this looks like a subtraction problem, but there's an invisible addition sign here. Yeah, and that's the definition of subtraction. To subtract means to add the opposite. So again, I'm going to add, and I'm going to line up my decimals very, that's not very careful, is it? 6.4. It's really easy to get offline if you're squirrely with the way you write. All right, placeholder here to keep everything lined up. Add them up. And then because you are adding two negatives, make the result negative. Okay. That ought to do it for the basic rules. I might have some terminology that we're going to be talking about. So now doing this type of summation, we call this a sum or a summation, typically involves all positive numbers. This is a little bit, we sometimes call this bookkeeping or accounting mathematics. It's sort of like adding up a list or a column of numbers. Typically only works with positives, because once you put a negative number into a sum, like we just saw, it throws off all the signs and things like that. So a problem like this would typically involve all positive numbers. We might see some geometry problems later in the lesson, or perhaps in part 2 of this lesson, depending on how things go, where this will have some meaning, some geometric meaning, like maybe the perimeter or something like that. Probably be perimeter if you're adding. So when you find the sum of more than 2 terms, typically we like to stack them. And it's really just for convenience. There's no real mathematical principle here. It's just it looks nicer. You stack everybody on top like this, and you can just add an entire column of numbers together. Make sure you keep them all lined up, and if necessary, put placeholders to keep everybody lined up. And again, a sum can be done in any order you like. You're just adding up these numbers. It really doesn't matter what order they're done in. Okay, let's do it. 7, 5, and 0, that's 12. That's 15. Carry the 1. That's 8. No carry. That's 6. And that's another 8. And there you go. This is the sum. All right, so that's addition and subtraction. Next, we're going to do multiplication. Also known as a product. You do need to be careful with multiplication symbols. And decimals. When multiplication symbols and decimals appear in the same problem, you need to be careful, because decimal points and multiplication dots often look very similar. There is a subtle difference, and that's their location. A decimal point is like on the ground, or we call this the foot of the number, the base of the number. I call it the foot. So you put it down at the foot. But a multiplication dot, we put in the middle, sort of in the center torso area of the number. If you think of a number like a person, you got the head, you got the torso, and you got the feet down at the bottom. Now, one thing you can do to avoid any of these problems is just not use the multiplication dot, go back to basic math and use the old school multiplication X or something like that. Something to indicate that you're not adding. Okay. Now, cool thing about multiplications, the decimals do not need to be lined up. Yeah, that's kind of neat. Now, if you want to line them up because you think it makes it look neat, and that's fine, you certainly can, but you do not need to line up the decimal points. And again, you want to think philosophically why? Well, think back to the section on fractions. If you were multiplying 9/10 times 5/100, and you're multiplying, you do not need an LCD. And that's really what lining up means. Lining up means you're making columns based on the denominator, the LCD. When you're multiplying, you don't need LCDs. So I hope nobody was making LCDs back in chapter 4 for the multiplication problems because they weren't necessary. Yeah, in fact, oftentimes if you do an LCD on a multiplication problem, not always, but oftentimes it causes more harm than good. It may cause the whole answer to come out wrong or too big or too small or whatever it is. Okay. With multiplication, you can multiply straight across, and you don't need an LCD. That would be, what, 45 over whatever, 1,000 or something. I probably would reduce that, but anyway. That's from chapter 4. Okay. So the same thing here. We don't need to line up the decimal points, but we do need to multiply. So 1 times 2, that's 2. 1 times 1 is 1. 1 times 6 is 6. Then put a placeholder. All right, that just keeps that spot so you don't accidentally write a number there. Some folks will use like an X. I've seen that when I'm grading, when I used to actually collect your work. Some people just put a little bar like that. I learned it when I was 10, and I just put a 0. It's just the way I've been doing it for my entire life, for most of my life. Okay, do it however you're comfortable with. And then move to the next digit. 4 times 2 is 8. 4 times 1 is 4. 4 times 6 is 24, and you really need to be careful. If you get squirrely and you get your numbers offline, you're typically not going to work out very well for you. And then now you want to add. Okay, so add, and you have to keep everything in line now. 2 and 0, 1 and 8, 6 and 4, that's 10, carry the 1. 1 and 4 is 5. And then a 2. Now the most important thing. Count the number of digits to the right of the decimal points. All right, so that's 3. Yeah, 1, 2, 3. So there are 3 places. Okay. Hope I don't screw up my camera by doing that. So we're counting 3 places. Start here. Start all the way at the right and move it back 3 places left. So count right, move left. 1, 2, 3. And so the answer is 25. I'm going to put the answer up here. Find the product. The product is equal to 25.092. Or 25 and 92 thousandths. Okay, so example 11. Now we got 0.27 times 0.075. We can also practice reading this just before I actually do the problem, since we're still early in the chapter. This number is read as 27 hundredths times 75 thousandths. All right, just to make sure that we're understanding the nature of the numbers. And the parentheses are there to imply multiplication. All right, you can put a parenthesis around the second value, or the parenthesis could be around the first value, or you could put parentheses around both values. All of those are equivalent forms of multiplication. Okay, now remember, when you're setting this up, you're going to set it up with typically the number that has more digits on the top and the number with the fewer digits on the bottom. And then I'm putting an X just to remind myself that I'm not adding, that I'm multiplying. Okay. Remember, it's the it's the bottom number that determines the number of rows. So that's the reason why you would want to do it with the smaller number of digits on the bottom. All right, let's go for it. Now I'm doing this the old-fashioned way. I'm sort of pretending as if calculators don't exist. If you're going to use calculators, I recommend using them out of abundance of caution, because you do need to know how to do this by hand. You could also use the calculator to check your answer. Sometimes I do it by hand, and then I regret it, and then I just will break out the calculator and say I'm going to do it that way. Okay, so 7 times 5 is 35, carry the 3. 7 times 7 is 49, plus 3 is 52, carry the 5. 7 times 0 is 0, plus 5 is 5. And then 7 times 0 is 0, but I could just leave that blank. Okay, now put a placeholder or something to imply that you're moving over one spot. Some people do something like that. I've seen people do that. I've seen people do this. There's lots of different placeholders. The most common is a 0, because it has no value. Next row would be 2 times 5. I like to cross off my old carries so I don't get confused. 2 times 5 is 10, so 0, carry the 1. 2 times 7 is 14, plus 1 is 15, carry another 1. 2 times 0 is 0, plus 1 is 1. Now, technically, there are 3 rows here, but the third row is all zeros. 0 times 5 is 0. 0 times 7 is 0. 0 times 0 is 0. 0 times 0 is 0. Now, I'm only showing you that because sometimes this first digit here is not a 0. And so I'm just showing you that the number of digits technically determines the number of rows. All right, this row is not necessary. Okay, and then now it turns into an addition problem. Yeah. So now we're adding vertically. 5 plus 0 plus 0. 2 plus 0 plus 0 is 2. 5 plus 0 is 10. Carry the 1. 1 plus 0 is 2. Now we have to be careful. With addition, you just line up the decimals and bring them directly down. But this is multiplication, so we want to count the spaces to the right of the decimal. 3 places plus 2 places is a total of 5 places. Now remember, you count to the right. Oh, you can't see that. Count to the right. All right. To the right of the decimal point. The right-hand side. But then when you come down here, start all the way to the right, and move left. All right, so you count right, move left. 5 places. 1, 2, 3, 4, 5. If necessary, put in some zeros to fill it out. If there's any blank spaces, you want to put zeros. And so the answer is 0.02025. So typically when you say this, you say 0.02025. Some people call these O's. Even I do occasionally, but we all know that they're not really O's, they're zeros. If you want to practice saying this, because I will ask this occasionally to, say the number in words or write the number in words, count the number of places to the right. So that's 10th, 100th, 1000th, 10,000th, 100,000th. Okay, so you know it's going to end with the word 100,000th. And then you would read it 2025 100,000ths. So if you were to say that, you would say 2025 100,000ths. Yeah, that's how you would say it. 2025 100,000ths. My face seems to have disappeared. Let me switch back to the other camera, for example. If you have a negative times a positive, it comes out to be a negative. So you can kind of predetermine before you even do the problem, before you even start calculating, make your decision now. Before you start, what's going to happen? If it's going to be negative or positive. Yeah. These are two negatives, so the rule is pretty clear. Negative times a negative is a positive. Now you can just ignore the negatives for the rest of the problem and just treat them like positive numbers. The order in which you multiply is, again, non-essential because multiplication is much like addition. It's commutative. But if you put the larger number of digits, whichever one has more digits on the bottom, you end up having to work harder. But you will get the same result either way. I like to put the smaller one on the bottom. So 7 times 9 is 63. Carry the 6. 7 times 5 is 35. Plus 6 is 41. Carry the 4. 7 times 8 is 56. 7 times 8 is 56. Plus 4 is 60. Put a placeholder. 3 times 9. Cross out your old ones. You don't want those anymore. 3 times 9 is 27. Carry the 2. 3 times 5 is 15. Plus 2 is 17. Carry the 1. 3 times 8 is 24. Plus 1 is 25. And now add. So up here we're multiplying. Down here we're adding. So 3, 8, 7, 11. Carry the 1. And then a 3. Count the number of decimals. 1, 2, 3. So we're going to move 3 places to the left. And then double check. Check. This is positive. If the rule of signs told you that it was negative, well, then you could make this negative. Again, that's all based on the original problem. Okay, one more. One more multiplying, and then I'll teach you some cool tricks, cool techniques. Okay, so decide now. You have a negative and you have a positive. Is the answer going to be negative or positive? It's going to be negative. You have a negative times a positive, so you know that the answer is going to be negative. All right, and now set it up and just ignore the sign now. 5.12. 2.001, or 2 and 1/1000th. So even though I put the smaller one on the bottom, it has less digits. It only has 3 digits. It's not the smaller value. 2 is at 2.001 is actually smaller, but it has less digits. I'm going to have to work a little bit harder now because now I've got 3 digits in the bottom. So if you're watching this and you think, well, I don't want to work hard, I want to work smart, I want to find a more efficient way to get it, then just switch the order. And your answer will be exactly the same as mine with a little bit less work. I just want to show you what happens if you have 3 digits in the bottom row. At least you got to see it once. 2 times 1 is 2. 2 times 0, 0. 2 times 0, 0. 2 times 2 is 4. Put a placeholder. 1 times 1, 1 times 0, 1 times 0, 1 times 2. Put 2 placeholders now. So the placeholders typically make the shape of a triangle here. And if there were more decimals, then the placeholders would continue to expand triangularly like that. You got 1, then you have 2, then the next one would be 3 placeholders, and so on. This will be my last one. 5 times 1 is 5. 5 times 0. 5 times 0. And then 5 times 2 is 10. And now I have to be very organized. Sometimes it might help you. You know yourself better than anybody else. If you're sloppy, and you know you're sloppy, just admit it, then draw these vertical lines. Kind of like freeway lines to keep you driving straight. You've got those lines to guide you from, getting squirrely on the road there. All right. 2 plus 0 plus 0, that's 2. 0, 1, and 0, that's 1. 0, 0, 5. 4, 0, 0, that's 4. A lot of zeros. 2, and that's just 10. I'm going to bring down the whole thing. And now count the decimal places. 1, 2, 3, 4, 5 places. Start here. 1, 2, 3, 4, 5 places. And now the answer should be negative. So that's going to be negative 10.24512. And that's our final answer. Okay, so let's multiply by 10. That's always fun. It's one of the most convenient parts of the decimal system. It's actually not a coincidence. It was done by design. The decimal system is designed to work very good with tens. I'm not very good at keeping track of where we're at, so I think we're at 15, but I don't know. We're next, wherever we are next. So multiplying by powers of 10 is very easy. Yeah. Just count the number of zeros and move the decimal that number I'm actually going to write the word number of places to the right. So for example, if I say 10 times, here, let me write it this way, 36.42 times 10. That's a power of 10. Yeah. So count the number of zeros. So there's 1 0. Yeah, there's 1 0. So the answer is move the decimal 1 space to the right. So the decimal moved 1 space to the right. And that's it. You don't need to use a calculator. You don't need to actually set up a problem with all, stacking the numbers on top of each other. You can just look at the problem and you get a free answer. So if I said 36.42 times 100, that's 2 zeros. 2 zeros. So we're going to move the decimal 2 places to the right. So the decimal point goes here. If this happens, if the decimal point terminates and it goes all the way to the end of the number, you can omit it and just say 3,642. It's technically 0.0, but you don't have to put the 0.0 on the right-hand side. You only have to put it if it lies on the left-hand side. Let's try another one now that you see the rule. Couple big ones. All right. And you can just do this entirely with mental math. In fact, I hope you do it with mental math. This has 3 zeros. So you're going to move the decimal 3 places to the right. So you have 0617.8, and now you may omit the 0. Because the decimal point is no longer next to that 0 anymore, so that 0 can be omitted. And now your answer would be 617 8/10. And for this one, 4 zeros, so 1, 2, 3, 4. Decimal point goes there. And that equals 140,923.0, or you can just say 140,923. If you really want, you can put a comma there so that you know that's 140,000, because I almost called it 14,000 when I first looked at it, but it's 140,000. If you don't put the comma, it's still correct. Now here's where the multiplying by powers of 10 gets weird. You have to memorize 2 different directions. So for large powers of 10, 10, 100, 1,000, 10,000, you move the decimal to the right. Memorize that. Large, right. Yeah. Lower powers of 10, like 1/10 or 1/100th, those are the smaller ones. They're small decimals. You're going to move the decimal to the left. Now, in my experience, memorizing a rule is relatively simple, right? You can say, oh, that's, I understand that rule. You've said it before. I get it. The problem is when you have two rules that are very similar, that's where, it gets a little bit more confusing, because I've seen students, occasionally when I'm, coming around and helping people, or even in office hours, if you come to my office hours, and the most common thing is you freeze up and you can't remember whether you're going to go left or whether you're going to go right. So these are now smaller powers of 10. Yeah. So this is 1/10. That's what I mean when I say small powers of 10. There's a more precise way to say that in the next class. I just don't want to spoil it right now. So I'm just going to refer to them as small. Yeah, 1/10, 1/100th, something that seems tiny. Yeah. You're going to move one place left. Move the decimal one place to the left. So starting right here, you're going to move one place to the left, and you're going to get 3.549. So this is 1/100th, or just 100th. So you're going to move the decimal 2 places to the left. Now, one thing I want to make clear is you're not moving the decimal on the 0.01. You're moving the decimal on the 18.06. Oftentimes, we just cross these guys out so that you don't accidentally move the wrong decimal. I can't tell you how many times I've, explained this and then had the student overdo what I'm saying, and I could see why it might sound like that, right? You got these decimal points, and you remember you're supposed to move them to the left, and then you move them both to the left, and then that screws the whole thing up. So I would just cross these guys out, and then look here and move 2 places to the left, 1, 2. So you get 0.1806, and yes, you need to put that 0. So it reads 0 and 1,806, what's that, 10,000ths? Yeah, or 1,806 10,000ths. Okay, so that's the idea. If there were a smaller decimal, 0.001, then you would move 3 places to the left. And 0.0001, you move 4 places to the left. Maybe I'll just do that instead of saying it. I don't want to just leave that one hanging. So this is 1,000th. Yeah, 1,000th, you're going to move. It's nice that it sort of rhymes. 1,000th, 3. Yeah. 3 places. Just make sure you move it to the left. So starting right here, 1, 2, 3 places. So you end up with 9.4348. And finally, and again, I like to cross that out so I don't accidentally mess with it. So just look at it, decide how many you're going to move it, and then get rid of it. Okay, once you've made up your mind. So this is 1/10,000th. That one doesn't rhyme very nicely. That's 4 places. 10,000th left. All right. Once you've made up your mind that you're going to do that, I like to just get rid of that, come over here, and move it 4 places. Now, if you don't have 4 places to go, you have to create places. So that's 1, 2, 3, 4, and then fill them in with zeros. And then finally, add an additional 0 after the decimal point so that it looks proper. Okay, and then this trick becomes very useful, and especially when we get into the word problems, which we'll probably have to wait until my second part of this lecture. But you can multiply big numbers now by using this trick. So suppose I wanted to multiply 5,000 times 6.074. Well, let's go ahead and call this part A then, because I'm going to actually do 2 of these. So if you wanted to multiply 5,000 by 6.074, or 6 and 74 thousandths, keep in mind that 5,000 is actually 1,000 times 5. Let's use parentheses. Yeah, that's what 5,000 really is, 1,000 times 5. So what you could do is ignore the 1,000 for a second. Yeah, just ignore. Don't forget about it, but just ignore it for a second. Multiply by 5 first. Yeah. So let's do that the way we've been doing it. 6.074 times 5. All right. 5 times 4 is 20. Carry the 2. 5 times 7, 35. Plus 2 is 37. Carry the 3. 5 times 0 is 0. Plus 3 is 3. And then 5 times 6 is 30. Yeah. And then count your decimal places. You want to make sure you do that now. So 3 places past the decimal, to the right of the decimal. So again, we start here, all the way to the right, and then we move back left, 1, 2, 3 places. All right. But don't forget that you have the 1,000 multiplied by, let's write it right here. 1,000 multiplied by 30.370. All right. Now, when you're multiplying by big numbers, like, tens, hundreds, thousands, large powers of 10, then you're going to move the decimal to the right. So now you're going to move this decimal back to the right 3 places. 1, 2, 3. Now, this sometimes drives people nuts because they think, well, if I moved it to the left, why am I just moving it back right? Well, you got to keep in mind that, well, first of all, it's a coincidence that they both came out to be 3. Sometimes you'll move this one to the left 2 or 3 places, and then you'll move this one to the right, whatever it happens to be. Maybe I should have done maybe 50,000. In fact, I'm going to do a part B in a second. So your final answer goes right back to being a whole number, 30,370. I don't recommend putting commas. You can put a comma like on your notes or something, but sometimes they get confused with decimal points. I'm not sure how the homework system reacts. Sometimes it accepts the commas, sometimes it doesn't. It's probably better just not to use them, right, unless it's absolutely necessary. Okay. just to emphasize this a little more, let's do another example. Let's call this part B. Let's do 0.0003 multiplied by, I don't know, 2.09. Same trick, same technique. We're just going to do it in the opposite direction. So keep in mind again that 0.0003, that is 3 10,000ths. So that is 1 10,000th. That's 1 10,000th multiplied by 3. Yeah, that's what that really means. And we're going to ignore the 1 10,000th for a second, and we're just going to multiply the 3 first, just like we did a second ago. So 3, 2.09, multiply, do that on Scratch. In fact, I've got a little room. Why don't I do it over here? 2.09 multiplied by 3. Sometimes you can do this in your head. You know, if it's a small enough number. Let's do this one. 3 times 9 is 27. Carry the 2. 3 times 0 is 0 plus 2 is 2. 3 times 2 is 6. So I probably could have done that one in my head. Move the decimal over 2 points, 2 places to the left. So 6.27. For something that small, you probably could have just done that. So now you've got 6.27, right, multiplied by 1 10,000th. Right. So this is a small number. Yeah, it's a small power of 10. Yeah, it's a fraction essentially. It really means, if you like to think conceptually, it means 1 over 10,000. All right, that's what this decimal actually means. It's a very, very tiny fraction, 1 10,000th. All right, and so remember, for small numbers, you're going to take the decimal and move it left. Yeah, you're going to move it left 4 places. 4 places. So I like to go like this, 6.27. Give yourself some room on the left to move, and now you're going to go 1, 2, 3, 4, and then put in all of your extra zeros. So your final answer is here. Okay. So just to make my answer look nice, let me come up here and put equals 0.000627. So that's an example of why. See, over here, when you're doing the mental math, you move the decimal to the left, right, 2 places. And then over here, I moved it to the left 4 places. So you never know how many places it's going to be. Well, I mean, you do know when you're doing the problem, but I mean, sometimes they're exactly the same. Sometimes this is 2 and this one's also 2. You know, sometimes this one's left and this one's also left. Sometimes this one's left and this one's right. Right? Right? Okay. So there's your answer. If you want to practice saying this, just before I go on to the next example, let's just practice it. So 10th, 100th, 1000th, 10,000th, 100,000th, millionth. Yeah, so this is 627 millionths. It's a very, very, very tiny number. Division. Typically, we use long division. That's the traditional way to do it. We won't be doing a lot of, the canceling type of division that we did in previous sections. Am I up to 20? What am I up to? 21? 20? I don't know. I'm losing count. I'm going to start off with something like this. 3.36 divided by 8. Okay. And so there should be no remainders in this section. All right. You got to keep going until termination, or until the decimal terminates or repeats. Now, in this lesson, since this is the intro, I know it's part 2, but it's still the intro of the operations, I don't think we'll have any repeating ones unless I just have it planned well. But I've looked at most of these problems, and I think that we'll be okay. I do have a whole section on repeating decimals for next week, but I don't really want to go there right now. So hopefully today everything will go well, and we're just going to end up with a bunch of terminating decimals. The repeating decimals will happen in 2.3. That's a little bit of a clue, because if you get a repeating decimal, it doesn't mean you did anything wrong. It just means that maybe that problem, it shouldn't have occurred in 2.2. I don't know. I haven't screened every single problem. There's thousands of different combinations, right? So I don't know what you're going to get. This is the one that I got today. All right, so we call this long division. The numerator is called the dividend. I do want you to know those words, so I'm going to write that one down. And the dividend goes inside. The denominator is called the divisor, and the divisor goes outside. Okay? The divisor must be a whole number in order to use long division. So it must be whole. If it's not, I'll tell you what you need to do to it. You need to make it a whole number. In this example, it's already a whole number. So we just go in and we divide it, okay? 8 goes into 3. No, it doesn't, so 0 times. Keep your eye on that decimal point. The decimal point does not move. It goes straight up to that spot right there, directly up. 8 goes into 33. Yeah, 4 times. 4 times 8 is 32. Subtract. That's not really a decimal anymore. That's now 33. Take away 32, so 1. Bring down the 6. 8 goes into 16 2 times. 2 times 8 is 16, and this is what we call terminating. Okay, and so your answer is 0.42, or 42 100ths. 42 hundredths. Well, you don't always get lucky. You don't always get a whole number as a divisor. So I want to make that clear. It's the divisor that must be a whole number. I think I only put one problem in which the divisor is a whole number, just to kind of get you going. And then the rest of them, the divisors are not whole numbers. So if the divisor is not a whole number, so suppose we have 45.43 divided by 7.7. Divisor is not whole. Okay, so how many decimal places does it have? To the right of decimal. 1. Okay, so what we're going to do is we're going to multiply numerator and denominator, numer and denom, by 10. Okay, If there was 2, then you would multiply by 100. Again, numerator and denominator. If there were 3, then you would multiply by 1,000. So I'm saying if it was 2 or if it was 3. In our case, it's 1. Yeah, 1 decimal. So we're going to multiply numerator and denominator by 10. So now you get a new problem, 454.3, multiplying that by 10. And now the denominator is whole. Now it's whole. So you can do long division. And this one I'm actually worried about. I'm already starting to sweat about whether or not it's going to terminate or whether it's going to repeat. I can't guarantee that it will terminate. I can tell you that I planned on making them all terminate, but with the thousands of different possibilities for these numbers, I don't know what's going to happen. Let's see. It's kind of a, never know what you're going to get. All right, so 77 goes into 4. Nope. 77 goes into 45. Nope. 77 goes into 454. Yeah, probably about 6 times. All right, I'm just guessing. 7 times 6 is 42, so it seems reasonable. So 6 times 7 is 42, carry the 4. 6 times 7 is 42, plus 4 is 46. Too big. Yeah. 462 is larger than 454. So that means guess again. So guess a smaller number this time. 5 is better. All right. If it's too big, guess smaller. If it's too small, guess bigger. Sometimes we call that Goldilocks. Yeah. Not too hot, not too cold, just right. All right, so 5 I think will be just right. 5 times 7 is 35, carry the 3. 5 times another 7 is another 35, plus 3 is 38. That's good. Okay, subtract. So I've got, let's see, we've got to borrow. So borrow from the 5, make that a 4. 14 minus 5 is 9. Oh, I got to borrow again. Make that a 3. 14 minus 8 is 6. And then 3 minus 3 is 0, but it's just 6, 9, not 0, 6, 9. All right, bring down the 3. And guess again. How many times does 77 go into 693? Well, 7 times 9 is 63. So let's try 9. Yeah, I always base it on the first digits, trying to get close to 69. So 63 is pretty close. Be careful with your decimal point. It goes straight up to there. 9 times 7 is 63, carry the 6. 9 times 7 is 63 again, plus 6. Oh, no, it's too big. Yeah, that's going to be, oh, no, it's perfect. 7 times 6, 7 times 9, I'm getting tired. 7 times 9 is 63, plus 6 is exactly right. Terminated. Yeah. So you got a remainder of 0, which is perfect. That's it. So the answer is 5.9. Let me just make that absolutely clear. 5.9. There's your answer. The answer is called the quotient. All right, I will be making you learn those words if you haven't already memorized them. So you have dividend, divisor, and quotient. And that's for when we get to the word problems when I say find the quotient or find the dividend or what is the divisor or things like that. So that you know what everybody's called. Okay. You could just use generic words like answer or result. But the problem with those generic words is they don't specifically tell you what it is you're talking about. It's like saying, hey, you. Are you talking to me? I'm called the quotient. You know, what am I? What is my value? What is my meaning? All right, example 22. $1.06 divided by 0.04. So the dividend is the first number, 1.06. That's the dividend. The divisor is the second one. Very important. Division is not commutative. So if you put the dividend and the divisor in the wrong position, you will get it wrong every time. Okay? So it's not like addition. Addition and multiplication, those are the nice ones, the liberal ones. You can do it either way and you're going to be fine. Yeah? But division and subtraction, those are non-commutative. They're stubborn. They must be done in that order or they will not cooperate. So count the number of decimal places. Yeah, 2 digits. 2. So you're going to multiply by 100, numerator and denominator. Okay. Always look at the bottom to decide how many to move. Now, I know these are both 2, but it's the denominator that determines. The divisor determines. All right, that's the ruler. So you're going to multiply by 100. I'm using parentheses because I don't want it to look like another decimal point. So that's going to be 106, and that's just going to be 4. No more decimals, right? Well, not yet. The decimals might come back. So if you want, you can put the decimal point right there just to be safe so you don't forget that that actually is a decimal. I like to actually throw in an extra 0 there just to make it look even neater, like this. Remember, the dividend, it's okay to have a decimal in the dividend. In fact, often in this chapter, the dividend will have a decimal. It's the divisor that must be whole, which technically has a decimal. It's just right there. Yeah, we typically don't write that. All right, let's do it. 4 goes into 10 2 times. 2 times 4 is 8. 10 minus 8 is 2. Bring down the 6. Now, I got to be careful. The 2 is above the 10. It's above the 0 on the 10. So I might want to be a little neater and put it right there. Because my next answer has to go above the 6. If I accidentally put it in the wrong place, it's going to be wrong. All right. 4 goes into 26 6 times. 6 times 4 is 24. Subtract, bring down the 0, bring up the decimal point. Decimal point goes up. 4 goes into 25 times. So the answer, the quotient, is 26.5. It's a long homework section. So I'll leave it to you to budget your time correctly. You know, every once in a while, use this to check your answer. Make sure that you're staying on target, but don't lose this. This is going to be the most valuable thing moving forward. It's a little bit of a balancing act, right? The calculator gives you time. It's more efficient. It's faster, but it doesn't have the same benefit mentally as doing it the long way. So I'm going to leave it to you to make your choices wisely. Okay, maybe a couple more of these, and then I'll teach you a trick for tens, which I hope doesn't blow your mind because we already have a trick for tens. And I'm about to teach you another trick for doing tens, but let me just do another one of these sort of regular ones first. I guess we'll do some negatives, huh? How about some negatives? How about negative 44.07 divided by 3.9. All right, so first thing you want to do is decide now, based on these values, what sign it has. It's the same rule as multiplication. So a negative divided by a positive is going to be negative. So now you've decided that. Now you can ignore it until the end. All right. Now don't forget. If you think you're going to forget, then put a pin in that and come back and check it before you're done. I'm just going to ignore it by not writing it. Okay. Look at the bottom. Denominator, divisor. That determines how many places? 1. So we're going to multiply by 10. It's very important that you don't custom make these, right? Don't do, the top has 2 places, so give that one 100, and the bottom has 1 place, so give that one a 10. That definitely doesn't work. It has to be the same value on the numerator and the denominator. And that value is determined by the denominator. Oftentimes, when you get really good at this, you will do all of this mentally. Mental math. Much more efficient because you don't actually have to do the multiplying, right? You're doing it all mentally. So that's 440 and 9/10, and then the bottom is now whole. It just becomes 39. And I hope this terminates. I'm always worried when I get these weird odd numbers and such, okay? So I'm going to make myself some space here. So I've got 440.9, and I've got 39 on the outside. That's my divisor. 39 goes into 44 one time. 1 times 39. Subtract. 44 minus 39 is 5. Bring down the 0. Wash, rinse, repeat. Wash, rinse, repeat. Yeah, this is called the division algorithm. So where are we at? 50 is our next dividend. So 39 goes into 50 again 1 time. 1 times 39 is 39. 50 minus 39 is 11. All right, bring down the 9. Bring the decimal point up. Don't want to lose that. 39 goes into 119 3 times. It's just a guess. I don't know. All right, let's see. 3 times 9 is 27. Carry the 2. 3 times 3 is 9, plus 2 is 11. So it's all right. It's smaller than 119. My remainder is now 2. So this happens sometimes if you run out of digits, you can just invent some zeros. Because those zeros are there, whether you just didn't see them, but they're still there. So you can now bring that down. 39 does not go into 20, so that's a 0. Invent another 0. All right. 39 goes into 200. All right. I don't know, 5 times? 6 I already know is too big, right? Because look, 117, so you can learn from the past, 117 was 3 times. Yeah, 3 times 39. So I know 6 is too big, too hot, yeah, and 3 is too cold. So it's either a 4 or a 5. I'm going to go with 5, and if that's too big, I can always back it down to 4. I don't even know if I'm going to have enough room to finish this. I might need another whiteboard. I'm going to get a whiteboard annex over here. All right, so 5 times 39. Well, 5 times 9 is 45. Carry the 4. 5 times 3 is 15 plus 4 is 19. All right. Remainder 5. Let's hope we can fit this in there. 0, add another 0. 39 goes into 50. That's easy. That's just 1 time. This is getting rough, huh? 1 times 39. I just realized the problem. Why is this? If this happens, I probably made a mistake. This little voice in my head was going, are you sure? Are you sure? Are you sure? I'm sure you're already sending me the email right now. I messed up. 5 minutes ago, I messed up. Look, I wrote 7, and then I started working, and then the next time I wrote 9. I don't know how that happened. So let's do a do-over. I told you in 2.2, this should not happen. The decimals should not go on and on and on and on and on. 5.2, sorry. In 5.3, we're going to have a whole lesson on repeating decimals where that will probably happen. It will happen, but not today. So I must have made a mistake. All right, so let's take it from here. So that's 440.7. So big correction. Oops. Corrected. All right, and the bottom was right, 39. My 9s and my 7s were getting a little sketchy there. All right, let's try this again. I know it's going to terminate because I made all these problems Terminator style. So they should all end with a 0. Terminated 0. Let's try this again. And if this doesn't work, then I got to really rethink my life here. 39 goes into 44 1 time. 1 times 39. Bring down the 5. 39 goes into 50 1 time. I can see it coming now. 1 times 39 is 39. Remainder 11. Bring down the 7. Not a 9, but a 7. Bring up the decimal point, and there it is. Terminated. 3 times 39 is exactly 117, and that's what should happen. Yeah, if that doesn't happen, that means you probably wrote the problem down incorrectly like I just did. Yeah. Okay, and then don't forget, way back when we determined that the result was going to be negative, the quotient is negative, so we're going to take our quotient, 11.3, and we're going to write it as negative 11.3. And that is the correct answer. I have to admit, I was panicking there for a second, and I almost broke out my calculator. So this would be a perfect time to demonstrate, being an intelligent person that just wants to get this done and doesn't want to go on nuts, with some crazy division problem. If that happens to you, I don't want you wasting half of your time on a quiz or a test on that. Just do it this way and make sure it's right, okay? I'm already done, but I can make sure. 44.07 divided by 44.07 divided by 3.9, and there it is, 11.3. Now the calculator is not going to give me negatives, at least not this type of calculator. If you have a more fancy scientific calculator, or perhaps a cell phone calculator or something like that, it will probably allow negatives. Mine doesn't. Mine's old-fashioned, positive number calculator. All right, I guess I'm going to have to end here, but before I let you guys go, I got to show you the trick for dividing. All right, and it's the same trick as multiplying, but it's a good place to stop. Dividing by powers of 10. It's the same trick or technique, that's what we really should be calling it, as multiplication. It's just opposite. So memorize, it's the same rule as multiplication, but opposite direction. Okay? In other words, if you are dividing by 10, well, what was the rule for multiplication? It was move it to the right. Yeah, move the decimal to the right. So for division, you're going to go in the opposite direction. You're going to move left. All right. And again, it's based on the power of 10. So this is a 10. It's got 1 0. So we're going to move it one place to the right. I cross off the 10. So that's 1976.0, or you could just say 1976. Okay. If it's 100, same rule as multiply, but the opposite direction. Man, I am really getting tired, aren't I? I keep making so many mistakes. I just wrote the word left, and look which way I moved it. I moved it right. 19.76 is the correct answer. I got to stop looking at the clock. It's making me panic here. So I'm moving it one place to the left. All right, so my arrow should go left. Let's see if we can get this one right. This is going to be 2 places to the left. I'm not going to screw this one up. 1, 2. So we get 0.45893. 2 places to the left. That's 100. $2,583.4 divided by 1,000. 3 places to the left. 1, 2, 3. I'm on a roll now. 2.5834. Well, if my mistake didn't confuse you, hopefully it educated you to the fact that nobody is immune. Nobody. You could do this for 50 years and still make the same types of mistakes. And not only that, it also illustrates the most common mistake is you think it's left, but then you go right. Or you think it's right and then you go left, right? It's the old which way did he go, conundrum that we get ourselves in. Is it left? Is it right? I don't know. Which way? Take a guess. Hopefully you get it right this time. It's left. So if that hasn't confused you enough, what happens if you are dividing by a decimal? And this, my friends, I promise will be the last example. Dividing by a decimal. Call that part A. Now it's going to go right. Again, it's the opposite direction. This is a power of 10. This is 1/10. So 1/10, you're going to move the decimal one place. Now this time it is right. Not left, but right. So that's going to be 354.6. Crossing this off, and moving the decimal one place to the right. How about 26.81 divided by 0.01? So this is 1/100th. So you want to move the decimal 2 places to the right. And again, I like to cross this off so I don't accidentally mess with that. And then come up here and move the decimal 2 places to the right. So you get 2,681.0. And you do not need to write the 0.0. You can just say 2,681. All right, the same process continues. I'm just going to call this part C. So this is 1,000th. So you're going to move the decimal, you could probably guess, 3 places to the right. And that ought to do it. So we're going to cross this off, move the decimal 3 places. And your answer is, or your quotient is 18,469.8. Okay. Yeah, I kind of knew that was going to be a long lesson, but there's a lot of problems, so get busy on it as soon as you possibly can. Again, a lot of this stuff's not due until next week, and you got some time to get through it. I will come back later with a part 2, which will just be focused on primarily word problems and geometry. And I'll do my best to make part 2 a little bit shorter. So until we meet again next time, this is Dr. Jordan. I'll see you on the internet.